All right, so our third and very strong intermolecular force is a hydrogen bond or hydrogen bonding. This is kind of a very weird name because the first thing we're going to say is that this is not a bond. It is an intermolecular force. So even though it's called hydrogen bonding, it is not a bond and is nowhere near as strong as a bond. So for example, if we have two molecules of water, this oxygen hydrogen bond is a bond, right? This is a bond right here, a covalent bond. Whereas we have this interaction between the hydrogen and the oxygen. This is what's known as a hydrogen bond or hydrogen bonding, but it's not actually a bond. It's just an intermolecular force, right? Remember, bonds are intramolecular or within a molecule. Intermolecular forces are between separate molecules. And so this hydrogen bond only has about 2 to 5% the strength of a covalent bond. So while it's strong for an intermolecular force, it's not that strong for a covalent bond. And a hydrogen bond is very similar to a dipole-dipole force. It's just super strong. So a hydrogen bond is basically just a super strong dipole-dipole force. And hydrogen bonding occurs with three types of motifs. So we have the oxygen-hydrogen bonds, which can participate in hydrogen bonding, NH bonds, and then FH bonds. And the reason that these three atoms bonded to hydrogen form these hydrogen bonds is because they're the three most electronegative atoms. And so they form very strong dipoles, which in turn forms very strong dipole-dipole forces that we call hydrogen bonding. So our most popular example of this is, of course, water, right? It makes up most of Earth's surface. It makes up most of our body. And we have oxygen-hydrogen bonds in them. And so these are capable of hydrogen bonding. So what happens here is that we have this OH bond, which is very polar, right? So they're going to have dipoles. And then we have the lone pair of this oxygen being attracted to the positive end of this molecule. And so that's what's known as a hydrogen bond. Again, it is not actually a bond. It is just an intermolecular force. And for an intermolecular force, it's very strong. So let's compare the boiling points of some compounds. So here we have methane, which is just CH4. Here we have ethane, which is basically kind of two methanes, two carbons saturated with hydrogens. Then we have formaldehyde, which is our polar molecule, but does not have hydrogen bonding. And then we have water, which is, of course, H2O, and it has hydrogen bonding. And if we think about the molar masses, this one, methane is 16 and water is about 18. So those two are approximately the same size, whereas ethane and formaldehyde have about twice the size of water. Not quite there, but close. And so you may expect the middle two to have higher boiling points. But again, hydrogen bonding is very strong. So when we take a look at these boiling points, this one has negative 162 degrees Celsius. This one, negative 89 degrees Celsius. This one, negative 19 degrees Celsius. And then water all the way up at plus 100 degrees Celsius. And you can see it's as small as methane. They have approximately the same size, yet it has a hugely higher boiling point, right? And that's because of these attractive intermolecular forces known as hydrogen bonds, which are actually not bonds.